Bobbin School for Philippine Craftsmen recognizes the rightful owners of the videos, images, graphics, and music used in this episode, and therefore doesn't claim any right over them. Copyright disclaimer under Section 107 of the Copyright Act 1976, allowance is made for fair use for purposes such as criticism, comment, news reporting, teaching, scholarship, education and research. Fair use is a use permitted by copyright statute that might otherwise be infringing.
Hello, grade 11 students. My name is teacher Guru Ann and welcome to your senior high school years. If you are wondering what lessons will you encounter on general mathematics, then this video will be a great introductory for you. What is really general mathematics all about? General mathematics is one of the core subjects of the senior high school curriculum. This means that wherever you are, what strands you are at, general mathematics is with you. It is an important discipline to study this subject because many of the roles require a basic or advanced understanding of mathematical concepts. Few of these concepts are knowing how to solve problems involving rational, exponential, and logarithmic functions, solving business-related problems like interests, annuities, stocks and bonds, and, of course, loans. And lastly, applying logic to real-life situations. Anyway, math is fun, isn't it? Now, let's begin the fun. Come and join me in exploring the first topic of general mathematics, the representation of real-life situations using functions, including piecewise functions. We will start the lesson by reading a story. Once upon a time, there were 7 senior boys: Boy, Jared, Job, Moby, Paul, Zane, and Gong. Close as they were, they did almost everything together. So when they learned about the school holding a Valentine's ball, they decided to find themselves some date. Incidentally, there were also 7 beautiful senior girls who were in the same class the boys were: Andrea, Keith, Karen, Angela, Kisha, Alexa, and Sophia. Our boys had each crush on the girls, and they have decided to ask them out for dates. Of the boys, Boy, Job, and Jared have something in common. They always believe that honesty and trust make any relationship strong. Boy asked Andrea out for the date. Jared chose Keith, and Karen was asked by Job. Gong, on the other hand, thinks he needs to be on the top of the pack. He likes to collect and select. To make sure he gets first date, he asked Angela, Kisha, and Alexa without the 3 girls knowing all of them are being asked out by the same guy. Moby, Zane, and Paul are very competitive that they all liked Sophia, so they decided to ask her out and agreed that whoever she picks, the 2 others would accept defeat. There are 3 kinds of relationships described in our story, but would all of these function? Let us meet the characters of the story and illustrate the relationships found in the story by having a mapping diagram. From the activity, try to answer the following questions. What type of correspondence is shown in diagram A? The answer is one-to-one correspondence. What type of correspondence is shown in diagram B? Correct. One-to-many correspondence. How about diagram C? Very good. The answer is many-to-one correspondence. Now, which correspondence represents a function? Why? How about you write an explanation letter on a piece of paper, then later on we'll try to see if your answer is correct. Let's proceed to the discussion of the following definition. A relation is any set of ordered pairs, x and y, where the set of all first coordinates is called the domain of the relation, and the second set of all coordinates is called the range of the relation. We can also define function as a relation where each element in the domain is related to only one value in the range by some rule. Or function is a set of ordered pairs x and y such that no two ordered pairs have the same x value but different y values. And using functional notation, we can write function as f of x is equal to v, or it can also be read as f of x equals v. So, how do we determine functions for mere relations? Let's look for the following. Every element in the domain is mapped to a single element in the range. There is no duplication of the first coordinates in the set of ordered pairs. The graph of the relation can only be intersected once when a vertical line is drawn anywhere in the graph. Now, if these three features are present, then the given relation is said to be a function. Relations can be represented in many forms. We will try to determine if the following represents a function. The first one is ordered pairs. We are given the set of ordered pairs A, and let's try to see if it's a function or not. The answer is, it is a function. Each first coordinate, or abscissa, is paired with only one second coordinate, or ordinate. This means that there's no duplication of the abscissa. As you can see, the blue ones are the abscissa, and the yellow ones are the ordinate. Next, we are given the set of ordered pairs B. Is it a function or is it just a mere relation? The answer is, it is a mere relation. Why did we say so? Because the first coordinate, 4, is matched to both 0 and -3 in the range. There is a duplication in the domain. The next one is table of values. We are given the table of values, x and y. Let's try to determine if it is a function or not. It is a function. Why? Because this is a one-to-one correspondence. And inspecting the abscissas, there is one value of x related to only one value of the y. There it is. Next, we have again the values of x and then the values of y. Let's try to determine if it is a function or not. It is just a mere relation. Why? Because this is a one-to-many correspondence. And by looking at the table, there is a duplication in the domain. The element 1 from the x is matched to 3 elements in the y. There it is. Okay, the next one is mapping diagram. We are given a mapping diagram of A. Let's try to determine if it is a function or a mere relation. Letter A is a mere relation because one element in X is not mapped to Y. B, is it a function or mere relation? B is a function because there is no duplication of the abscissa or the first element. And last, C, we are given the mapping diagram. Is it a function or is it a mere relation? The answer is it is a mere relation because the correspondence is a one-to-many correspondence. Now, going back to the activity that we had from the story, if your answer is A and C are functions, then you are correct. Note that the only relation that would make a correspondence not a function is if it is a one-to-many relation, just like letter B. And of course, if one element is not related to the other set. Okay, proceeding to graphs. We have the first graph. Let's try to determine if it is a function or not. The first one is a function because if you will drop a vertical line to anywhere of the graph, the vertical line will only pass at one point. The second graph is not a function because if you will drop a vertical line, it will pass 2 points and that will be 2 and negative 2. Hence, this is just a mere relation. So, are you still with me? Well, I believe you are now ready to represent functions as piecewise functions. Let's define piecewise function. It is a function that contains several expressions depending on restrictions. So piecewise functions, you will see 2 or more equations, and then you will have some conditions of the x's, or that is called the dependent variable. So the dependent variable is denoted by x, while the independent variable is denoted by y. Let's try to illustrate it by using the situation. A user is charged 200 pesos weekly for a particular mobile plan, which includes 50 free text messages, and text messages in excess of 50 are charged 1 peso each. You will represent the weekly cost of text messaging using the function T of M, where M is the number of text messages sent in a month. You will have 10 seconds to answer the question. Okay, time's up. Let's try to see if your answers are correct. So the solution is the cost of text messaging can be T of M is equal to 200 if M is greater than or equal to 0 but less than or equal to 50. And that will be 200 plus the quantity of M minus 50 if M is greater than 50. Let's try another one. We have the situation. A jeepney ride costs 7 pesos for the first 1,400 meters, and each additional integer kilometers adds 2.50 pesos to the fare. By using a piecewise function, represent the jeepney fare in terms of distance d in meters. Again, you have 10 seconds. Time's up. Let's try to see if your answers are correct. The solution is f of d equals 7 pesos if d is greater than or equal to 0 but less than or equal to 1,400, and 8 plus 2.5 times the quantity d minus 1,400 if d is greater than 1,400. So I would like to give emphasis on this solution because there is a deduction of the pre-restrictions, that is 1,400 deducted to d. Okay, so since you're still with me, young mathematicians, you must be having a great time. Why don't you try to answer the activity I prepared for you on Quizzes? You will download the app, and I'm sure you will love to explore everything in there. Just click in the link, flash on the screen, and don't forget to fill in your complete name for my reference. I will be checking your work. Thank you for watching this video. I hope you learned a lot, and see you in our next video lesson. This is again Teacher Girly Ann signing off.